So I made a simple command line interface for my program. You enter an algorithm specification and then a difficulty level. So breadth first, easy. There you go. Shows the different states, the moves that you go through, and then some summary statistics, number of moves, cost, steps, and peak number of nodes stored on the queue. You can also, instead of specifying difficulty level, you can specify a particular problem. Row first, 0 is the whole. Same sort of result. Alright. So onto the code. I represented an 8 puzzle internally as a list of integers which is restricted to be a permutation of 0 through 8. As far as the successor function, I basically just implemented as swapping 2 tiles and restricted it down to you can swap the 0 with one of the things next to it, and then just filter down to say, well, not all of those will always make sense right now, so only return the ones which make sense if you're on an edge or a corner. Let's see. Alright, on to the search tree, or to the search. So the main loop I kept as simple as possible. Right here, you simply pop something off the queue. If there's actually nothing on the queue, then you've completed without having found anything. If there was something, see if it's one of the goals, then return. Otherwise, add its children and recurse. Let's see. So all the magic happens inside the different kinds of queues. The queues are so I made an interface for a queue, pop, add, and size, the basic operations we need, and a few different implementations centering around just a stack, a regular queue, and a little more complicated is a priority queue, and then useful for helping to not repeat states and doing some iterative deepening stuff was a way to wrap a queue in another queue with a stateful predicate to say whether or not you actually add something when you try to add it. And let's see, so this made modifying search for the different algorithms pretty easy. LIFO queue for depth first search, FIFO for breadth first, A star, just use that priority queue, uniform cost and best first are just really just variations on A star. Iterative deepening is a little more complicated. A fairly complicated predicate for whether or not you add something to the queue, taking account of both the max depth and some logic to try not to repeat states, though still allowing it if you see the same state at a lower depth. And then just iterating through the basic search step with different depths. I checked for duplicate states by applying one of those stateful filters, the state just being a set of puzzle states I've seen before. Simple enough. And finally, the heuristic I designed was just a weighted Manhattan distance, so weighting it by the tile value itself.